Why stars twinkle? Hello students, welcome to the world of astrophysics. We live in this universe which is huge. Isn't this really beautiful? But students, when you look at this universe, I think there's one thing missing. Of course, the stars are not twinkling. So let's make them twinkle. So here we have the stars twinkling. Students, when you were in kindergarten, you studied this poetry, this wonderful poetry. Twinkle, twinkle, little star, how I wonder what you are. So let's put that query to rest and understand how stars twinkle, or why do stars twinkle. To understand this, the first thing we need to understand is stars are point source of light. Now why are they point source of light? Is because they are very far away from us. And as they are very far away, we use a unit to measure that is called light year. Now students, what is light year? Light year is the distance traveled by light in 1 year. Now can you imagine? Light is so fast. The distance traveled by light in 1 year is 6 trillion miles. Let's take an example of the closest star. The closest star is Alpha Centauri. And this closest star, Alpha Centauri, is at a distance of 4.22 light years. So you can imagine how far is the closest star to us. And as the stars are very far away, they are considered as a point source of light. Now let's go to the actual understanding and see why stars twinkle. Now students, we know Earth is surrounded by atmosphere. Now let us look at this atmosphere. The lower layer of the atmosphere is denser. And as we go up, the air becomes rarer and rarer. So I can say the topmost layer is rarer, and as we come down, the air becomes less rarer and less rarer. So these are the different layers of atmosphere. Now students, when you look at the star, the light from the star comes. Now this light has to pass through different layers of atmosphere. So at every layer, I'll make a normal. Now we know when light travels from rarer to denser, it bends towards the normal. So you can see here, the light is bending towards the normal. At the second layer, once again I make a normal. Once again, the light will bend towards the normal. And in this way, the light takes a curved path and enters the observer's eye. Now when it comes into my eyes, we don't see curved, we see straight. So when I'm looking, I will feel the light is coming from this point. So the previous position where the star was is called the real position. And now the place where I see the star is the apparent position of the star. So students, when you look at the stars in the sky, what you see is the apparent position of the star. Now students, the atmospheric condition is continuously changing because the seasons are changing. In rainy season, the climatic conditions are different. In summer season, the climatic conditions are again different. And oh, in winter season, the climatic conditions are so different. Now, because of this changing climatic condition, the atmospheric condition also changes. Now, as the climatic condition is changing, the intensity of light from the star coming into my eyes is also changing. So you can see star becomes dim, then it becomes bright. Now, as less light comes from the star, star becomes dim, again more light comes and the star becomes bright, and this effect of dim and bright to our eyes appears as twinkling of stars. So students, twinkling is nothing but appear and disappear effect. And this was the understanding of how stars twinkle. Students, this is a very important concept from exam point of view. So if this comes in exam, how do we write the points? The first point, stars are point sources of light as they are very far away. The second point we write is the refractive index of air in the given region in atmosphere goes on changing continuously and randomly. Now, when the atmosphere refracts more light towards us, the star is seen bright. Now, when the atmosphere refracts less light towards us, the star is seen dim. Thus, due to change in refractive index of atmosphere, stars appear twinkling at night. So, these are the points of the answer. Thank you.